What we're going to do is move into a new unit. We're going to be looking at solving systems. There's 3 different ways that we're going to be solving systems: graphing, substitution, and elimination. The first one we're going to start with is graphing. Now, when we're talking about graphing a system of equations, what we're doing is talking about graphing 2 equations. So when you look at this example, what we're going to be doing is we're going to be graphing the first equation, graphing the second equation, and our goal is to see where the 2 equations meet. And wherever the 2 equations meet, we're going to be writing an ordered pair. So an xy point, and that right there is going to be our answer. And that's how we're going to solve it using systems, solving systems using graphing. Now, for our first example, what we're going to do is we're going to go off of a basic example of x equals 2 and y equals -3. So for the first one, with x equals 2, we go along the x-axis at 2. There's no y-intercept because this only has an x-intercept. And then we draw a vertical line. For the second equation, we have y equals -3. So we go to -3 on the y-axis, and we draw a horizontal line. Now, once again, our goal is to see where the 2 lines meet. And we see that the 2 lines meet right here, which would be the ordered pair 1, 2, 1, 2, 3. So that would be 2, -3. For the second one, we're going to do the same thing, except these are a little bit more difficult. We have slope-intercept form. So we're going to plot the y-intercept, which is -2. Our slope is 2, which is the same thing as 2 over 1. So we go up 2 to the right 1. I'm going to do this again to make sure my line is straight. Up 2 to the right 1. And then I draw my line. For the second equation, my y-intercept is 1. I start at 1 on the y-axis. My slope is 1/2, so I go up 1 over 2. I go up 1 over 2 again. That right there is my line. And then what I'm going to do is I'm going to graph it, and the ordered pair 1, 2, 1, 2. So it would be 2 and 2. So looking at the third system, once again, what we're going to be doing is graphing each of these equations, and we're going to see where they intersect. The first one, our y-intercept is 2, so we plot a point at 2. Our slope is the number in front of the x. This is just a negative, so we know that it's -1, which would be -1 over 1. So it would be down 1 to the right 1, down 1 to the right 1 again, just to make sure my line is straight. And then for the second one, y is not by itself. So we're going to get the y by itself by first subtracting the 2x. And I have 3y equals -2x plus 5. Then we're going to divide it by 3. And we get y equals -2/3 x. And then 5/3 is the same thing as 1 and 2/3. I'm going to plot a point at 1 and 2/3. I'm going to go down to 1, 2. I'm going to go over 3, 1, 2, 3, and I'm going to draw my line. Now with this one right here, my line is a little awkward. It looks like it crosses right here at the ordered pair 2, 0. I'm going to double check it because I'm not really confident about my answer. It almost looks like it could go somewhere around here or here also, just because of where I put my y-intercept. Notice that it's not a solid 2 or a 1, it's 1 and 2/3, so I'm kind of guessing where it goes. So I'm going to plug in the 2, 0 into each of the problems. If I plug in a 2, -2 plus 2 is 0, so it works for the first equation. For the second one, when I plug in a 2, I get a 4. When I plug in a 0, I get a 0. 4 plus 0 is 4, not 5. So it doesn't work. So I'm going to try this other one. It looks like it might cross over. No, it looks like it might cross over here. Let's try this. That is the ordered pair 1, 1. So I have 1 and 1. I'm going to see if this one works. So if I plug in a 1, that would be negative 1 plus 2, which is 1, so it works for the first one. If I plug in a 1 and a 1, that would be 2 plus 3, which is 5. So it actually does work right here. So my problem was I probably should have had it right up here, went down 2 to the right 3. I guess it could have went through like that, and that would have been a better graph. So the nice thing about each one of these is that if you don't feel very confident with it, you could plug it in to see if you got the right answer. Take some time, try those next 3 and see how you do. So looking at letter D, first thing that we're going to do is we're going to graph our first equation. So we have negative 1. I'm going to draw a vertical line at negative 1. The second one is negative 2 for y. So at negative 2, I'm going to draw my line. And I see that it crosses right here, which would be the ordered pair negative 1, negative 2. Now for the second one, my y-intercept is 1. So I plot a point at 1. My slope is 1 also, because that's 1x. So I go up 1 to the right 1. Or I could go down 1 to the left 1, just to make sure my line is straight. For the second one, my y-intercept is 3, so I plot a point at 3. It's a negative slope, so I'm going down 1 to the right 1. I do it again, down 1 to the right 1 again, and I draw my line. And I see that it crosses right here, which would be the ordered pair 1 and 2. So looking at our last example, once again, our whole goal is to graph 2 different equations and see where they intersect. So my first one, the y-intercept is 3. I plot a point at 3. My slope is negative 2, or negative 2 over 1. So I go down 2 to the right 1, down 2 to the right 1 again to make sure it's straight. Now for the next equation, I want to get the y by itself, so I'm going to subtract the 3x on both sides. That gives me y equals negative 3x plus 3. So I plot a point at 3. I go down 3, 1, 2, 3. I go over 1, down 3, 1, 2, 3, over 1. And that right there gives me my line. And I see that it crosses right there on the y-axis. So that would be the ordered pair 0 and 3.